Okay, so here we have this. This is Odoo 12 normal environment. Okay, this is a base database with base add-ons installed. I'm going to start by opening a shell. No, sorry. First of all, I am going to open a PG activity monitor so we can see queries being executed in the database. And then I'm going to open a shell with click Odoo, and I will just make some change, something like editing the country of a partner, just something basic that some user could be doing. Okay, so simply pick up one partner and set some country. So you see that the cursor is opened here in the PG activity because you can see it is idle in a transaction. Okay. Now let me show you that I have some I have some change that I made. You see that here this is just adding in the base add-on. I am adding a unique country ID. Why am I doing this? Because this is something that a unique country constraint. Sorry, this is something that an add-on could do. Okay, and by doing it here, I am changing the SHA of this folder, so an auto update should be triggered in the base add-on. So let me just open it again, and then I am going to make a normal update without this auto update system. Just this, and so it will try to install this constraint, but as you can see, the query becomes blocked because there's another query that is modifying one record in this field where I am trying to install this constraint. So there is a conflict, and usually this session here in the middle should finish, commit, but sometimes while in production it becomes a deadlock where the constraint locks this query and this query locks the constraint. So none of them can continue. And this is a real problem because now the user is locked and the update process is locked also. But it could happen that a lock is a normal lock, that we are waiting for this one to finish, and when it finishes then we continue with the update, and it would be a normal lock. So we cannot use a timeout for none of them because both processes could take a lot of time if they are doing a big query or a big amount of queries and still not be locked. And we cannot also kill everything if there is a lock in the database, because this is also something normal that could happen. So we need to use a timeout for interlocks, for some queries, some processes actually blocking other processes. And if this happens, and this is for very old queries, then it means that we have a timeout here, and this should then block the update system, because we don't want to block the production user. We only want to block the update process, which can be rolled back and then start again when no user is logging anything. Okay. Also, as you can see, I cannot stop this unless I kill it externally, so I'm going to do it right now. It's just let me check which is the process. It's 1, 2, 3, so it's a pit. Okay. And the container is this one. Here I will just kill here, which is direction. Sorry, this should be inside the container, possibly. Well, I think that I can kill it from the other side. Should be. Send another terminate signal. Okay, doesn't process signals, as you can see, when we are in this mode. So after all, everything I can do is just force it to stop. This is for sending 3 term, and if it doesn't finish in time, it kills the process. Okay. But killing this process will not actually kill the query that is locked, as you can see here. The query remains open, and it's something a little bit stupid, but when the update mechanism stops, the query doesn't stop. So let me just kill it from here. Let me see, blocking, no, waiting query, this one, and then just kill it. Okay, so we have again the same query that we are launching from the Windows menu. Fine. Okay, so after all of this, you can see that I couldn't stop it, I couldn't kill it, both of them became blocked. So let's try with the DB watcher here that I am opening. I just launch this auto update. It will detect the change in the base add-on folder. It will start updating, and it has a timeout of 30 seconds. You see that it found a lock, which is this one. It's gonna check every 5 seconds in case some locks are found. And here you can see the timeout. It's 20 seconds right now, so the next loop it will find it's more than 30 seconds lock. Okay, it failed, and then what does it do? It kills the query, so it doesn't become locked here, and killing the query actually kills the update process. So the user can continue going on, then issuing the commit, and when it issues it, I'm not gonna issue it, I'm just gonna close this session. Yes, no commit. So finish. and launching the update again without any other cursor going on, any lock actually, because other queries not locking are not blocked. There is no problem. It will not detect all queries, only the queries that actually are locked. And as you can see, there's an error here while installing the unique constraint, but it's normal because there are more than one partner with the same country. This is expected. But as you can see, it is actually updating the base add-on as expected. And I can stop it, and the update will stop, and a message will be sent. So what this means in practice is that the usual behavior of stopping Odoo, updating, and then starting Odoo again will not be altered at all because of this change. But if you update Odoo in parallel, then it will detect these interlocks, and in case there is a lock, it will stop the update process. So the user is not locked, and then it will just let you know it failed because of this interlock, and you can start the process again until it goes in, if it works. And when it is finished, then you can restart the production instance of Odoo. So the users have this new code base with all the updated